Good evening, everyone. I'm Tina McAndrew, the library director in Stow. And as you just heard, we are recording this tonight for Stow TV. So if you could please keep yourselves muted, it just eliminates the background noise, but feel free to raise your virtual hand or your regular hand or put your questions or comments in the chat. We will be monitoring those during the course of the evening. On a personal or professional level, I want to thank Arnie and his team because the Randall Library construction project received a $500,000 decarbonization grant. We got notified yesterday, and it was a lot of work on his part. So thank you, Arnie. Yay. Some good news for a change. And with that, I will hand it over to Sharon.
Okay. I'd like to welcome you all to this session.
Yes, there he is.
Okay. Sustainable Stow and Randall Library have been in partnership for 4 years doing this speaker series on a variety of topics. And tonight we have a very exciting topic, which looks like there's a lot of interest in it, which is you have a heat pump, now what? So I'd like to start out by just getting a sense of the audience and their experience. If people know how to raise their hand, let me see by raise of hand, how many people already have heat pumps? Okay. Give it another minute. Looks like we have quite a few. How many people? All right, if you put your hands down now. How many people are thinking of getting heat pumps? Again, raise your hands. Okay. And one other sort of setting question. How many are here in Stow or Hudson? How many? Raise your hands if you're here from Stow or Hudson. Then I'm assuming a lot of people are not residents of Stow or Hudson, and that you live in another town. That would mean that you would have, as your provider for electricity, you would either have National Grid or Eversource. And that also makes a difference sometimes in your cost estimates. So this is really, I'm very excited. We have a panel of real experts who are here to help answer your questions. So let me introduce you first to Joel Boucher, if you would wave, let people know, yes. Joel Boucher is the comfort advisor for Boucher Energy Systems. He's worked in the industry for about 35 years. And he has been Boucher Energy has been installing heat pumps since the 1980s. They design, install, service both air source and geothermal systems in existing homes and new net zero homes. Dave Korn, and Dave Korn doesn't have his video on because he's saving his cell energy. He is a senior engineer at Ridgeline Energy Analytics, an energy engineering firm located in Stow, Massachusetts. He has led field studies of heat pumps in Maine, Massachusetts, Vermont, and Connecticut in hundreds of homes. And finally, we have Bob Zog. So Bob, if you would raise your hand.
Right here.
Okay. Bob, let me make Bob is a founding member of the HeatSmart Alliance. This is a volunteer organization that promotes clean heating and cooling systems in Massachusetts communities. As a consultant, he's led numerous evaluations of residential and commercial building energy use, focusing on space heating and cooling and domestic water and refrigeration. So with this illustrious panel, I want to sort of set the ground rules. We have quite a few people online. So what I would recommend is if you have questions that you would like answered, if you would please put them in the chat. Is everybody familiar, I hope, with how to do that? And I will then go through and answer pose those questions to our illustrious panel. And hopefully we'll get all the questions answered. So without further ado, I'd like to start off with a question. With climate change and unpredictable temperatures, can heat pumps keep our homes comfortable in these new conditions? So, Bob, would you like to take that one?
Sure. I mean, I think the answer is yes, although we never know exactly how extreme conditions might get. But we're going to have, let's put it this way, we will have much bigger problems long before heat pumps fail to heat and cool our homes with changing temperatures and climate conditions.
Okay. Joel or Dave, is there anything you would like to add to that?
Sure. This is Dave Korn, and apologize for the no video. We meter a lot of heat pumps in a lot of conditions. So one of the projects we worked on is putting heat pumps into mobile or manufactured homes where we take out their furnaces and put in those homes, and then we meter them. And we have seen heat pumps heating fully, working very well at negative 16 degrees Fahrenheit. And that's the actual temperature, not the wind chill. So it very rarely gets to negative 16 in Massachusetts. So my answer is absolutely, heat pumps are going to be able to heat your home down to some pretty cold temperatures. Of course, depending on sizing and you talking to your contractor. But anyway, I'll leave it at that.
Great. Thank you. Is it okay to adjust the temperature of heat pumps? When do you do that? Joel, what's your thought about that?
Well, you should adjust it so you're comfortable in your home, whatever that temperature is for you. What it actually says in the thermostat is this important as, hey, are you comfortable? But in terms of turning it up and turning it down a whole bunch of different times a day to save energy, it's not like your old system, especially the new variable speed equipment. So we would always recommend that people set it at a temperature they're comfortable at, and then just leave it there. The idea of programming up and down a whole bunch of times during the day, there are some studies that have shown that can actually make the system consume more energy than if you just simply left it alone.
Great.
Did you see the related question?
So Dave and Bob, are there anything you'd like to add to that?
Yeah, just to emphasize, the idea here is to be comfortable, so do what it takes to be comfortable. That's one. And if it's your bedroom that you want to keep cool, there may be ways you can do that without adjusting the thermostat constantly. If you have a forced air system, you maybe can just close off the supply registers in your bedroom and keep the door closed during the day, and your bedroom will just stay a little cooler. So there's often ways to do that. But certainly if you're going away for a few days in the winter, yeah, turn your thermostat down. Makes sense. But if it's just overnight, as Joel said, for a few hours, you're unlikely to save much money by turning down the thermostat at night.
Okay.
Just one quick add. I agree with everything that Joel and Bob said. One thing nice about heat pumps is that you can zone your house. So if you've got a furnace with one thermostat, you have one zone, which means the whole house is going to be 68 or 70 or whatever temperature. You can't spot heat different rooms. With heat pumps, you often can. So I see people, they'll heat their bedroom to one temperature, their living room to a different temperature. This is when they have non-ducted heat pumps. And then maybe there's a back room they don't use much and they keep that pretty cold. So that's one way to save energy and do what Joel said, which is to set it to be comfortable.
Great, thank you. We have a question from the audience. Lori asked, what is the best way to keep our heat pumps running most efficiently? Which was related to what you were saying, set it and forget it, or turn it down when you're leaving or sleeping and up when you return. But what about setting it twice a day? So basically, I think you've answered that question, but specifically about setting it twice a day. Is there a reason for doing that?
I could speak to that. Well, since Jimmy Carter was president, we were all told to put on a sweater and turn the heat down to save energy. But that was typical giant, oversized oil and gas fossil fuel systems that only ran at one speed. Most of the heat pumps that our firm installs, actually all of them, are variable speed. So if you're turning up and turning it down to heat the house up faster, make it more comfortable when you're turning it back up, that system is going to speed itself up. And if it has electric resistance heat, if it's a ducted system, it's going to turn on the electric resistance heaters to warm your house faster. And that's a big no-no, because as soon as those electric heaters turn on, that's going to take about maybe 3 or as much as 4 times as much energy as running the heat pump itself. So turning it up and down twice a day just to save energy, no, we would not recommend that to somebody for the majority of heat pumps that our firm installs.
A follow-up question to that, and Joel, I'll direct this to, what is electric resistance heat?
That's something that's common in a ducted air source heat pump. It's a heater that goes inside of the air handler, and it's there for, they'll kick in if it's extremely cold out, or they'll also kick in if you turn the thermostat up and down. And it's there as it's a backup to the heat pump. If you have a mini split system with wall heads hanging on the wall, those units do not contain electric resistance heaters.
Okay, hopefully, Lori, that answers your question. Okay, if there were no others, then I'll go. So how do you, so this may also get to the questions you were, the answers that you said, but you may have more responses you want to do with this. How do you manage a heat pump when it gets very, very cold? And how does the temperature affect operations? And what is too cold for effective operations? And I'm sure that's going to vary with what the heat pump you installed. Is that correct? Joel?
Sure, the performance of the heat pump varies with what it is for a heat pump, and also who put it in. Was it sized properly, and was it installed properly? In terms of what question is it effective at, they can be effective at any question, at any temperature. They can heat the home as long as they are properly engineered. In terms of cost, sometimes people, when they say effective, they mean what's cost effective. That can vary depending upon what town you live in, what you're paying for electricity, and what your other source of heat might be. Is it oil? Is it gas? And what are you paying for that? So in terms of, are they effective? Will they work? Yes. But cost, that's a separate issue.
Mm-hmm.
I might just build on that and say, for those who are in Stow or Hudson, where you're effectively paying a marginal cost of 12 cents a kilowatt hour, I would argue that there's virtually no temperature at which the heat pump is less expensive to operate compared to fossil fuels. If you're with Eversource or National Grid or some other utility, that's not true. But you enjoy in Stow and Hudson incredibly low electric rates, and I can't imagine why everyone would not put in a heat pump in Stowe and Hudson.
The other question was, what temperature do they stop working? You're just not going to see those temperatures in Massachusetts anymore. Different brands rate to different temperatures. And Joel will know this, but the different brands rate to -13 or -15, depending on which brand. And then some of the brands now coming out are rating to -22. It's very rare to get below -5 in Massachusetts in the last 10 years. So your heat pump's going to work and not be damaged for temperatures that you're going to see.
Great. I'd like to, there's a question, I'll get to just a minute, Jen. But I'd like to follow up on the question about sizing. You've mentioned, Joel, in your response about sizing. So in your experience, Dave, what's the issue, or Bob, what's the issue around sizing? And what do people need to ask when they are talking to a contractor about making sure that it's sized right? And what does that mean, sized right?
Dave, do you want to start?
Sure, and I'd certainly want Joel to jump in on this too. So heat pumps are a little bit different than as Joel said, the big oversized gas or oil systems you have. Those systems, if they put out a certain amount of heat, they put that heat out no matter what. Heat pumps actually, their capacity declines at very cold temperatures. So if you're down to -5 degrees, your unit can start to put out a little bit less capacity. Stepping back, that what they mean by sizing is how much heat can that heat pump put out compared to what your house actually needs. So you'll want your contractor to take that into account. And then lastly, there's two ways of going about it. If you want to only use a heat pump, you'll design it so that your heat pump has capacity to heat all the way down to a pretty cold temperature. And then again, Massachusetts doesn't get as cold as where we work in Maine. The other design, and I've seen this in some of the homes in Stowe, they'll put in a ducted unit and they'll leave the oil furnace in place, and they'll design it instead to heat down to say 10 degrees, and then the oil furnace will take over when you get below that. So there's different philosophies. I'll leave it at that and let everyone else jump in.
Yeah, I'll just add to that. It is, I think, an important question to ask each installer who's proposing equipment is, how are you going to size this? How are you going to determine the design heating load and the design cooling load when you provide a quote, and will you confirm that after I make a down payment? It's a fair question. And doing sizing correctly can be time consuming. So it's one thing, it's one way, hopefully you can differentiate among installers by how well they answer that question. But there are trade-offs. Even modern heat pumps that can operate at a range of capacities, there's still a warm enough temperature where you still need heat, where you can't get below a certain heating capacity out of the heat pump, and it will have to cycle on and off. And if it does that a lot, it will impact efficiency. So if you size the heat pump large enough to handle extremely cold temperatures, depending on the equipment, you could be compromising its efficiency at milder temperatures. So the installer has to do this balancing act and work with the homeowner based on the homeowner's values and desires to come up with a system that's right for that homeowner and right for that home.
Joel, is there anything you'd like to add?
I think those comments are exactly correct. I spend a lot of time speaking with homeowners, trying to decipher what they really want and what they really need. And that greatly affects how we're going to lay the system out and engineer it. And sometimes people have an idea of what they want in their head, but then after talking to them and working through it, we find out that a better solution maybe is something different than what they initially thought. So some people want to eliminate all their fossil fuel. Some people only want to offset some of the fossil fuel, or they want to use mini split heat pumps in just a couple of rooms. So then that sizing equation is different, right? It's different from your next door neighbor. If you live in a development, your house could be identical to your next door neighbor's, but I may have a different solution. So it's about finding out what the needs of the household is, and then figuring out, okay, there's mathematical formulas to figure out, well, exactly how big should the heating and cooling system be for the home if it's entirely replacing the fossil fuel. And it's important to do that math if you're going to do that. If you're going to somebody's home and they just want to put a small mini split in one living room and one bedroom, that's a lot less relevant. So I guess the answer is there is no singular answer to that question. You simply want it to be sized properly to do the job you're asking it to do.
Okay. I have a very specific question. It says if this person has a boiler with a baseboard heating and an indirect hot water tank, and wanted to know what the heat pump options to fully or partially convert the home.
Yeah, this is Joel. So that's something that we do every day of the week. So the answer is, what are the options? You know, is it option A? Is it option B? A lot of times the answer is yes. It could be either one of those things, depending on how much of your fossil fuel you want to offset and how much of the house you want to heat or cool with the heat pump. If it's baseboard hot water heating, we could build a ductwork system in the whole house to do that. On some houses, that's very difficult and very time consuming. So with baseboard hot water heat, a lot of times a better choice is the mini split wall hung type of heat pump. Can be a lot more cost effective than trying to build ductwork in a house that has baseboard hot water.
I can add to it. I'll give a vision to the future where we're going with this. So agree with everything, exactly what Joel said for today. Makers are coming out with heat pumps now that will make hot water to heat homes. And there's a lot of engineering discussion I won't bore you with, but we're actively testing a couple of different brands of those right now. So I'd say for today, you can't directly replace it, but in the future, you'll be able to put in a heat pump that will generate hot water to actually continue to use your baseboard, and make your hot water. So we're testing a system right now that'll do just that. The issue is it won't cool though. So you can't run cold water through your baseboard and cool your house. So if you want heating only and domestic hot water, it's coming. In another year, you'll have a couple of different options to do that, but it won't cool your house. So just understand that.
Okay. Bob, I have another question that is probably right for you. And if you could share your screen, the question is, could someone please explain how heat pumps work? I know there is an exchange of cool and warm air.
Well, yeah, I don't know if I have a great slide for that. I'm going to give you, I am going to share my screen. Give me 1 second here. And this is the simple explanation that we've evolved to. Used to give a much more complicated explanation, but basically a heat pump is a device that moves heat from a cooler place to a warmer place. We all have heat pumps in our homes. We just don't call them heat pumps. Our refrigerators, dehumidifiers, air conditioners, all effectively use the same type of technology as a heat pump. And heat pumps are available for heating your home and cooling your home. That's one piece of equipment that's doing both. And that's worth emphasizing because I think a number of people miss that point. The heat pump is performing the function of your furnace or boiler and the function of your air conditioner in one piece of equipment. And let's point out that they're available for domestic water heating. So for heating water for your showers and sinks and laundry and whatnot, have heat pumps available. You can get a heat pump clothes dryer. You can even get a heat pump for heating your swimming pool. There's more complicated explanations, but you know, I think the best analogy is we all understand that heat flows naturally from warm places to cool places, but we're trying to move heat from a cool place to a warmer place, and that takes a mechanical device to pump that heat, and that's basically what a heat pump is. And yeah, hopefully that's helpful.
Great. Thank you very much. In recent snow, ice, freeze weather, the outside unit became ice crusted on the back of the unit. We checked because of a louder sound, then removed the ice, but not sure if we have checked that regularly. Any thoughts about that? So that goes to a broader question of what maintenance should one be doing with one's heat pumps?
So, but go ahead, David.
No, I was going to say, Joel, you answer first, and I have a quick story after that.
Okay. So that's a bit hard to answer because I don't know what type of heat pump he or she is referring to. If we're talking about a air source mini split type heat pump, they have a fan on one side and coils on the back side. So if those coils are completely iced up, they will get a little frost on them from time to time, and then the unit will defrost itself. It's supposed to melt all that ice off. But if the back of that unit's frozen solid and it's got an inch of ice or something like that on it, it shouldn't. It should have gone into defrost at that point, and it should have melted that off. So that's something you should probably be calling your installer about, sending them a picture of it at least, so they can take a look, because that really shouldn't be happening. It shouldn't build up, you know, an inch or two of ice on the rear of those coils. And you definitely shouldn't be out there with a hammer and screwdriver or something and chiseling that off, because you could very easily damage the coils and the fins that are underneath it. That's what I can kind of extract out of that question. But without having seen the actual unit and knowing what brand and type, it's hard for me to be more specific than that.
Dave?
Yeah, I'll add to that. Agree with everything Joel said. Do not take a screwdriver and start to chip it off. You'll have a little leak with refrigerant after that, probably. I have seen this only happen once, and what caused it was a metal roof, and we think what happened. I didn't see it happen. I only came afterwards. We think it was slush and ice coming off the roof, encasing the back of the unit. In that case, I was able to take the ice off because it wasn't embedded in the coils. It was sitting out a couple inches from the unit. But again, call your contractor, have him look at it. You don't want to be damaging your unit.
Okay. Our temps seem to fluctuate when we leave our mini split on a set temperature. For example, we have the temp set at 68 degrees and the room temperature might show a temp of 60 degrees after a cold night. So I guess the question is, why? Who would like to take that? Dave?
The question I ask is, how cold was it outside? If it was really cold out and your heat pump isn't sized to heat your house, your whole house, that could happen. So a properly sized heat pump, even if it's, when we say negative 10 degrees out, we see the house staying at 68. If your heat pump is sized to only partially meet your load, that could be the reason. The only other thing I've seen is some makes of heat pumps, depending on how they're set up by the contractor, can have a pretty broad swing, not down to 60, but I've seen a plus or minus 4 degree swing that can be fixed by the settings. But I certainly want to hear Joel and his installation experience on this one.
Well, what David just said is correct. Depending on how it's sized, it might not quite keep up when it's really cold. But there's also a wide variation in the units themselves from the manufacturers, how they work and what kind of temperature they control and how tight they do it. So we do all different types of heat pumps. I got to kind of assume here a little bit that we're talking about a mini split style heat pump. Most of the mini split style heat pumps are Japanese or Korean manufacturer. And the temperature sensor is not down on your wall like it would be with a regular system. The temperature sensor is inside that unit up by the roof, which is way up high on your wall. So you could have set that, it'll say 70 degrees with the on the wall hung unit, but your thermostat on the other side of the room, which is only 4 feet off the ground, may read a different temperature than it does up by your ceiling where that unit's mounted. So there's one thing. And the second thing would be, because they're Japanese and Korean manufacturer for a lot of them, they were engineered and designed around Celsius. So they're allowed to let the temperature fluctuate from the temperature you set it at, 1.5 or 1.7 degrees Celsius up or down, which can easily be 3 or 4 degrees difference. Your old programmable thermostat for your oil or gas system on the wall, a lot of those keep the tolerance really tight. They might only allow the temperature to vary just 1 degree. So that's kind of inherent to those if you're using the remote control. There are some other thermostat variations you can put on some of the brands, which would tighten the swing up.
Yeah, I just want to add that this is anecdotal, of course, but we've had our heat pump for 12 years now. And the thermostat virtually never fluctuates from the set point temperature. It doesn't even fluctuate a full degree either direction. It keeps it right at 68 or whatever we set it at. So heat pumps with the right, controls can do amazingly accurate temperature control as well.
Okay.
Yeah, I was just going to add to, I have seen, I won't name the brand, but I've seen a brand out there really let the temperature move a lot, and then it turns out there's a dip switch, some sort of setting that the contractor can change, and I've seen that work. So check with your contractor if you're seeing a swing of more than a couple of degrees. As Joel said, you plus or minus 2 or 3 degrees might be just what you're going to get, but if it's more than that, again, either it's a sizing thing on a very cold day, or call your contractor because there's a setting that can be changed.
Okay. Back to sizing. Arnie basically said, I've heard it is better to somewhat undersize a heat pump rather than oversize the heat pump. Is this right in some situations?
I fear we're going to have some disagreement among the panel on this one. So my answer is no. I don't agree with undersizing it. I think that these are variable speed machines. I think people have gotten on the wrong path to try to make them small as possible. And I'll stop there and let others disagree.
I'm kind of with David on that, assuming that the contractor has done the math properly to size it in the first place. I've been around the industry for a long time, and I think some of that feeling and that kind of mindset got going because for a long time, many contractors did dramatically oversize equipment. So the thought was, well, okay, undersize it a little bit because you're really not, because you were oversizing it to begin with. So maybe that's where some of that comes from. The downside to undersized equipment is that you're gonna, whatever your backup heat source is, you're gonna get into it a lot more. So if you have a ductwork type system, which has electric backup heat, it could be air source heat pump or geothermal heat pump. We do not want that electric resistance backup heat running, right? And if that, or running very minimally. And if you dramatically, if you undersize that heat pump, you're gonna get that resistance or backup heat having to come on a lot more.
Yep. Yeah, I think we have a quorum or whatever the word is for majority on this. Yeah, I just wouldn't go that way. I think the mentality also comes from boilers and furnaces are classically oversized by a factor of 2, or Joel can disagree and say it's a different number, but whatever, way oversized. And heat pumps aren't in that same category. They're, on the heating side, they're not being oversized by a factor of 2 or 3. So you don't have that huge cushion to push against. So anyway.
And I'll just weigh in. I mean, I generally agree as well. But the caveat is what's it mean to undersize or oversize? Because again, it depends on the home. It depends on the homeowners and what they want. Depends on the brand of equipment that the installer is trying to use. There's a lot of factors that go into how a heat pump should be sized. But one thing I have heard, and maybe Joel, you can speak to this. I have heard some installers say that they're quote unquote undersizing for heating a little bit because they're concerned about oversizing for cooling. My guess is that that's kind of hogwash in this climate in Massachusetts, but I'd love to hear your thought on that.
Well-
Was that sent to Joel or, oh, go ahead, Joel.
Sorry. Well, I think that depends a lot on the equipment that you're using. For our firm, all the equipment we use is variable speed, and that includes our geothermal equipment. And there's very few companies that make geothermal equipment in variable speed. But that kind of solves that dilemma. So you don't really want to super oversize an air conditioner because then it's not going to dehumidify well. But having a compressor speed that can ramp up and ramp down to meet the load really, really helps. So the reason for that is that when we're air conditioning a house, we're only cooling the house off maybe 10 to 20 degrees from the outdoor temperature. But if I'm trying to heat the house to 70 and it's 10 degrees out, I got to raise the temperature 60 degrees, right? So in general, for most homes, the heating load is higher than the cooling load. So that's where that question comes from. But with the variable speed equipment that we have, we can eliminate a lot of that issue. If it's just a single stage piece of equipment or a two-stage piece of equipment, piece of equipment that just turns on and off, then that can definitely be a problem where if you size for heat, you're going to be way over on cooling.
Yeah. I think that Joel agreed. I think what we're talking about here, though, it's all variable speed. And we're seeing now in New England, there's been a couple 100,000 heat pumps put in. And because of our climate, every single one of them is quote unquote oversized for cooling because we're meeting our heating loads. And we're just not seeing huge problems. We're not seeing problems on the cooling side. Joel, unless you got something to disagree with me on, I'm not seeing it. What do you think?
Yeah, I haven't really seen those cooling issues. Again, as long as the system's not crazy oversized for heat, and most importantly, it's a variable speed. So you can take that, and variable speed means the system can speed up or slow down. So in cooling, the system will just run slower and therefore not be oversized. I have seen it on single stage equipment, but that's one of the reasons that our firm does not install single stage equipment.
Okay, I have another question, which is I would like a heat pump hot water heater. So we're moving to something else, but the person, Kate's basement is 500 square feet and low ceiling and dampish. Is it an option?
I can take a crack at that. I'm a big fan of heat pump water heaters. Well, I can say in our house, we have a 450 square foot basement. It's not low ceiling though. It's a normal 8-foot ceiling. We run a heat pump water heater, just two of us in the home, and it works fine. I have never measured the temperature difference. I would say the basement probably runs about 5 degrees cooler than it would otherwise. If you have a low ceiling, most heat pump water heaters do stand quite a bit taller than a conventional tank water heater. So it would be more an issue, do you have the overhead clearance? But I think in general, most manufacturers say if you have an 8x10 or a 10x10 space for the water heater, if the room is at least 8x10 or 10x10, that's big enough for a heat pump water heater. And if your basement is dampish, that's even more reason to put in a heat pump water heater because it may help with that dampness. I say may help. They do tend to dehumidify, but they don't dehumidify on demand. So you might still want to have your regular dehumidifier in your home, but you might find that the heat pump water heater allows your dehumidifier to run a little less. Unfortunately, in our home, we don't experience that. That's not, it depends on how the heat pump water heater is designed and the humidity you keep your basement at. We don't see a lot of energy benefit from lowering their dehumidification load, but some people see a huge benefit. So I would say, you know, it sounds like you probably would be a good candidate in general, as long as you have the enough height to put the actual physical tank in. And if you don't, there are other configurations that you can get. There's a solar assisted heat pump water heater that you know, I think is a much lower height, and it puts the heat exchanger outdoors, so it doesn't even have any cooling effect on your basement. If you're worried about, if you're, for example, putting a water heater in a closet, you know, and you don't have any ventilation. So you can even put in a heat pump water heater in that situation if you get the right equipment.
Right. So Tony mentioned that so far we're talking a lot about heat pumps, and you've mentioned a couple times, Joel, about thermo. So he said that the discussion was generally about air source heat pumps, and he wanted to, if the panel could discuss ground source heat pumps, which are far less affected by outdoor temperature. Is that a true statement, or other experience on that?
Sure. So an air source heat pump is absorbing heat from the outside air. So as the air gets colder outside, even though the heat pump may be capable of extracting heat from the air at 0 or 5 or 10 or 20, it uses a lot more kilowatt hours of power to do it. Geothermal systems are by far the cleanest, greenest, least expensive to run system, because instead of extracting the heat from the outside air, we're taking the heat out of the ground at a pretty constant temperature between typically we like to oversize our ground loops a little bit. So typically we see our ground loops even at the end of the winter being about 40 degrees. So you think about an air source heat pump that's outside, it reaches its peak efficiency on a nice sunny day when it's warm and dry, it's not raining, it's not snowing, and it's 40 or 45 degrees, right? That's an air source heat pump sitting outside your home. The geothermal system basically thinks it's that perfect, nice October 45-degree day every single day of the year. So they have a big advantage in terms of efficiency over an air source type system.
Okay, Dave or Bob, do you have any other thoughts about geothermal?
No, I think
Yeah.
that covers it.
Yeah, I just add, there's a couple other advantages as well. One being that once it's installed, there's no mechanical equipment exposed outside. So aesthetically, you don't have to look at a box of equipment sitting outside your home. Yes, when it's going in, it can be a bit messy, but once you've re-landscaped, it's nice. And another advantage, most geothermal heat pumps, the heat pump is factory packaged. It's all the refrigeration loop is all packaged at the factory. So there's no refrigerant piping connections to make in the field, charging and that sort of thing, where, you know, if that's done right, it's not an issue. But if an installer is trying to get things done quickly, you can get some contamination, or you can get a leak. So a geothermal system is probably less likely to ever have a refrigerant leak in its life. Yeah. So,
But the other issue with
definitely.
geothermal, you need to have so much land, and it has to be to do it.
No, you don't really have to have much space, because all we're doing is we're bringing in a well truck and we're drilling a couple of holes, or maybe just one hole. So you do have to be able to get the truck in your yard, right? So there's going to be enough room to get that in there, but it's not like you're digging up your whole yard, laying pipes horizontally or anything like that, the way you might see on the internet. That's generally just done in the Midwest. Up here, just backing in a well truck, drilling a hole, and putting the pipe right in the ground. And the diameter of that hole is about 8 inches around. So there's really not too many places where we can't do it. There are some, but not too many. I did see something pop up in the chat. I think it was a question about a cost, something about the cost coming down. And the answer to that is no, and that's for every type of heat pump, right? When was the last time you went to the store and bought something and the price went down? Well, for us as contractors, it's the same. Actually, looking at new vans, replacement vans of some of our older ones, since before COVID and now after COVID, for us to replace a van is almost 50% more expensive than it was just before COVID. So our costs are constantly going up. So whether it's an air source heat pump or ground source heat pump, just like everything you go out and buy, everything we go out and buy is more expensive. So I don't see the cost coming down.
So to follow up with that question is, so what is the kind of property tends to work best for a ground source heat pump? And what happens if you have wet soil or bedrock?
Rock is fine. It's easy for the well driller to drill through rock. It is, if you have to get trenches between the house and where the hole is, that can be a bit difficult if there's a lot of rock, but it's actually easier for a well driller to drill through rock than it is through sand or soft soil.
So doing a slight change, what has been your experience with integrated controls that automatically switch between the heat pump and a backup system?
Well, that's a great question for Joel. I can say there's been a lot of progress over the years, and but there's still probably room for a bit more. And there's also a lot of discussion about how to actually do the control logic, whether to have a switch over temperature or do what's called the droop strategy, where you run the heat pump as long as it can physically provide the heating load, and then you switch over to your backup fossil fuel system only when the heat pump fails to meet the thermostat. That method is the best in terms of energy savings because it allows, or carbon footprint, because it allows you to run the heat pump as often as possible. But it may require, it may result in some temperature swing in your home that may or may not be a comfort issue. But I'll let others build on that.
Joel, I know you generally install integrated control systems.
Well, those are required to be installed in any town where you're going to be applying for the Mass Save loan or Mass Save rebates, which Hudson and Stow don't get to have because you don't participate in that program. But as somebody else mentioned, your electric rates are unbelievably low, so be happy you're better off with that than getting a rebate off the cost of a heat pump. There's a variety of different ways to do it. It's different for every manufacturer of heat pumps. Some of those systems work better than others. We have done that for years and years. That's not new. My dad sold heat pumps in the late 1970s on top of a wood furnace, right? That was real popular back then, and they were integrated together. So it's not like it's new tech. The tech's just gotten better. Some of them do work better than others. The ones on the ducted type systems, if you will, seem to be a bit more reliable than some of the brands that integrate mini split wall heads into your system. There are definitely issues with some of those because it's all Wi-Fi based, and we've had issues where indoor units drop off the network and then you have to go into your phone or your tablet and reconnect them to the network. People do find that a bit on the annoying side. When everything's communicating properly through the Wi-Fi, it works just great, right? But That's just one of the downsides of a Wi-Fi based system with the mini splits. It can sometimes be a little bit glitchy.
Okay, I think that answered the question we have here, which is I have the Sumo Cloud apps on our cell phone, and sometimes it doesn't seem to take with the
Right.
setting, and it's offline. And then when we click zone, suddenly it starts working again. And was wondering if there was an upgrade that they should be getting.
If that's a particular brand. Joel, do you work with that brand?
Yes,
They
we
call
do,
it,
and that,
yeah, go
Yeah.
ahead, sorry.
yes, we do, and that is definitely a pain point. With that particular brand, I do know that they have pushed out updates through the web, and that I also know that they have a company here in the U.S. Because one of their engineers is actually one of our clients that they've hired to, that particular brand is hired to work on the software and improve it. So we expect that over time that setup's going to get better.
Yep. So we do this in manufactured homes in Maine, where we have we do a hard switchover point instead of the droop. Either way works. We set them to between 5 and 10 degrees Fahrenheit, and then we switch over to their existing furnace from the heat pump. This is mostly really very far north, where we can't get a big enough heat pump into these manufactured homes. So, and it works.
Okay. I have a rather long question. It's certainly an experience. Occasionally, okay, I'm gonna have to get my plug. Occasionally at quite cold temperatures, our mini split outside unit starts humming somewhat loudly. Is that the defrost system kicking in, or is there something wrong with the unit? The sound is somewhat unnerving, and it usually causes me to shut the unit off until it warms up a bit outside. So Joel, do you know if that's humming is the defrost unit?
Well, the systems speed up the harder they have to work. They're very, very quiet. So a mini split type system is the quietest type of unit in the industry, but the compressor runs faster and faster the harder it has to work. So if it gets real cold, that's when that compressor is probably going to be at full tilt, and it's going to make more noise, just like flooring the gas pedal in your car. And then when they do go into a defrost cycle, the noise changes. So it could be one or both of those things. You're hearing it be louder because it's working harder, just like if you have the gas pedal floored in your car, or it could be in the defrost cycle.
Also, from the same person, the person servicing their mini split system each year wants me to keep a bait box containing rodent poison under the outside unit all year long. He says this will keep mice from entering the unit and chewing on the wires. Unfortunately, I find that I'm killing many chipmunks as well as mice, and I'd rather not do that. Do I really need this year-round bait box?
Well, I'll start on that. I'm sure Joel will have something to say. I mean, mice aren't stupid. They like things that are warm, and when your compressor runs in the wintertime, it's warm and they like to get next to it. I can speak from experience because I cleaned out a major mouse nest that was sitting right on top of my compressor in my outdoor unit. I guess I was lucky they didn't chew on any wires, but I don't know. I don't do this, and I wouldn't bother with it. You know, I don't know. I guess anyone can get unlucky. Critters can chew on wires. That's just life.
Other thoughts, Joel, Dave?
I've never seen someone do it, honestly. I've been out to probably 400 different houses and haven't seen it done. So I get the theory. I just don't know that you have to do it.
The mice can get in the units. They can cause damage. Last year, they got into one of our service vehicles and caused several $1,000s worth of damage. We don't necessarily recommend somebody put a bake box behind it. But as everybody else said, any place that's warm and nice, that's where they want to be, and they'll love to get in your car or the lawnmower in your shed, and they're happy to get in a heat pump. But we don't necessarily recommend somebody put a bake box behind it.
Yeah. We did have a comment from one of the our participants. that Breit poisoning is the black box is very bad because obviously it killed predators. It also has a problem with our birds. Those are all the questions that we have in the chat box. And let me take a quick look at the questions you know, just one interesting question. I said, if I put in a heat pump for cooling, and that was my original motivation for AC, could I then switch it to heating, or would that require a different heat pump? I need someone else to come and take a look.
Well, if it's a heat pump, they shouldn't have to do anything. They should be able to run it in heating mode. And I certainly would encourage them to do that if it's already there. You know, if the installer didn't size it as a heat pump, maybe it's a little undersized, but you know, why not use it as much as you can?
Okay, Dave, Joel?
Well, it's very common for us to go to houses where people want to replace their central AC system. And then many of them actually only ask us for a central AC. And my question I always ask them back is why? Why don't we just put in a heat pump at the same time? And yes, you use it in AC. And when it goes to the heating cycle, you use it in heating. A lot of times that's a ducted type system that somebody already has in their home. And the ductwork, it is probably not large enough to begin with, even for the AC, and definitely generally not large enough to heat the entire house when it's really cold, because that takes more energy. We have to move more air through the ducts, and if they're not real big, then you know, your backup fossil fuel type system is still going to come on. But sure, go ahead and turn it on, run it as much as you can. A lot of those systems can heat the house just fine down to 30 or 25 degrees, and here in Central Mass, that's, you know, the majority of our winter. It's warmer than that. You're going to be able to wipe out between generally 50 to maybe 65% of your fossil fuel usage, even if that thing was sized just to be an air conditioner.
One other sort of a basic question. What is the general maintenance required, and how often should you be maintaining your heat pumps?
Pretty much all the manufacturers of heating and cooling equipment, be it fossil fuel or heat pump, are going to recommend that gets looked at by a professional once a year. Many of them stipulate in their warranties that you have to do that to keep the warranty in force. Of course, in between that, you may need to be cleaning your filters or replacing them, etc. But be it an oil boiler, a steam boiler, a furnace, gas or oil heat pump, really doesn't matter. They generally need to be looked at once a year.
The only thing I would add to that, if you're burning fossil fuels in your home and you don't do an annual maintenance check, you're taking a huge safety risk. You could get carbon monoxide poisoning, you could get all kinds of issues that you really, really don't want to deal with. Whereas with a heat pump, it's not a good idea, certainly, to not do the annual maintenance. If you do go to every other year, for example, you're probably not going to introduce a safety issue into your home. You might introduce an efficiency and heating capacity issue, but you're not going to create a safety issue in your home.
The other question I have is, do you always need a backup system for the heat pumps? And this is also related to a question that we have, a very specific thing, that they have a Carrier Energy Star 3R39 heat pump manufactured January 2014. Below 40 degrees, it is not economical to use. They switch to the oil furnace, and they have Eversource as their electricity provider. This is a 1,200 square foot house that is super insulated. Is this normal for this system to have a backup at, and have to use the furnace at 40?
Well, I don't know that particular unit. I can tell you if 2014 to now is an eon when it comes to technology. So the best systems today would far outperform that Carrier unit. So it might be a bit different question with the new heat pump. Although, truth be told, there are a lot of cheap stuff out there that might not be any better than what you have. But the key also was that they're mentioning Eversource, which is a much higher electric rate than you have at Stow and Hudson. So while the heat pump, depending on what it is, the heat pump could heat the house just fine at 15 or 20. That does not necessarily mean it's cheaper to operate than operating some of the fossil fuel, again, depending on how good the heat pump is and what you're paying for the oil and what you're paying for the electricity, which varies widely. That's why we kind of do it on a town by town basis in terms of cost comparisons.
The only thing I'll add to that is a new modern heat pump would easily be able to heat your whole house. The 1,200 square foot well insulated house, you wouldn't even need that big a heat pump to do that. So I just want to make sure that people understand that heat pumps can do that. But otherwise agree with Joel that the economics of it are going to depend a little bit on what you're paying for energy on a given month.
I just like to add, again, a small super insulated home, whatever you use to heat it, it's not going to be a very big bill. So the way the question is worded is really based on economics, which again depends, we're paying upwards of 35 cents a kilowatt hour, something like that with Eversource these days. I'm not familiar with this model either, but I can say we put in a Carrier heat pump in before this in 2012, and I'm going to answer a different question. We have a similarly sized home, but it is definitely not well insulated. It is late 70s construction, and it's whatever it is. And our heat pump will heat the home down to, probably 15 to 17 Fahrenheit with no backup heat whatsoever. And it does have resistance elements in the air handler, as Joel described earlier, for backup when it's colder than that. And the heat pump will actually run, I don't know how much heating it's doing, but it's at least contributing something all the way down to 0. And that's a 12-year-old heat pump. And I don't know how much better that particular model has gotten since then. But there are a lot of differences in heat pumps available. We're speaking tonight in very broad brushes. So when we say, heat pumps heat down to minus 15 or minus 20, some of them do, some of them don't. But again, in this case, whatever you use to heat this home, it shouldn't cost much. And if you're concerned at all about carbon emissions, run the heat pump as much as you can and just use the oil when you absolutely cannot meet the heating load. And you're not going to make much difference in your annual fuel bill. I really can't imagine, unless this heat pump is just a complete dog, which it could be. I don't know.
Okay. The same person was interested in the difference in cost from an air to air versus geothermal water to air heat pump system. And I assume, so in broad terms, obviously the costs are going to vary with where you are. and who's your service provider. But in broad terms, is there a difference in the cost of using a geothermal versus an air source?
So assuming everything else is equal, that you're comparing a really good geosystem to a really good air source system, and that both systems are properly engineered and properly installed. Very, very important, that part. The geosystem is going to win every single time. So from one of the air source brands that we use, their very best equipment can get close to the efficiency of a geo when it's 40 or 45 degrees out and sunny. How often do we have 40 or 45 degrees out and sunny? Any day that it's not that, the geosystem's ahead. And as the temperature gets really cold out, an air source heat pump has to defrost more and more. It has to use some of its energy to melt the ice off of the coils outside, which we kind of had the question about that earlier. A geothermal system never has to defrost. So it's significantly better. Again, assuming everything is done properly. But in some small, really well insulated homes, it doesn't necessarily make sense. So we did a house last year up in Canton. It's a super insulated shell, what people would call like a net zero home. It's about 1,100 square foot ranch house. We have one small mini split system in that home that heats the whole thing because the house is small, super insulated, really well built. It's not worth the investment in that house to try and even do it with a geo, because the smallest geo I could buy would be dramatically oversized, right? But in general, the geo system is going to win.
Okay. I have two more questions, but I'm going to have to call it off because we really have gone past our time. But real quickly, is the cost of installing a geothermal is versus the air source heat pump, I assume, is quite different.
So the first thing to know about geosystems is that they're going to use ductwork. So if your home doesn't have ductwork in it, then you could put mini splits in it, which don't require ductwork, at a much, much, much lower cost. So that pricing is really all over the map. In a new home, the cost is really not that much different. So in any new home we do, we're going to put ductwork throughout that entire home, right? That's a fixed expense. And if it's done well, a pretty big expense. No matter if you're attaching a fossil fuel system to it, a geo system, or an air source heat pump, all that work of building the infrastructure within the home is the same cost. And the geo system is going to get a 30% federal income tax credit, which dramatically lowers that cost. So it varies house to house so much that there's no way for me to answer that other than to say, yes, if you do not have ductwork in your home and you're comparing it to a wall hung mini split system, then it's definitely going to be quite a bit more expensive because we would have to build a ductwork system.
Okay, one last question. Is there, do you know when the resistant supplemental heat source starts up? Is there a sound or something that will tell you if it's starting up?
Well, I think if it's a mini split, a ductless mini split, multi-split system, as Joel mentioned earlier, they do not have electric resistance elements built into them. So if there is any electric resistance backup, it's probably the legacy, it might be a legacy baseboard electric heating system. But if it's a I shouldn't say conventional, but if it's a central ducted heat pump with resistance built into the air handlers, I think most thermostats, I don't know this for sure, at least some thermostats available will say, backup resistance heat is on or something like that on the thermostat. Other than that, it's a little hard to tell.
Okay, so this is specifically resistant supplemental heat source. The person had a Mitsubishi mini splits.
Yeah, so it probably does not have any backup resistance heat in it.
Well, that's all our questions, and I really wanted to thank our three presenters, our panelists, for answering the question. And I hope that this session has been useful to people. And again, I want to thank Bob, Joel, and Dave for some great information and so very helpful. This is a technology that we're all learning more about, and we'll keep learning. So, and thank you, Tina, for once again hosting us.
You're welcome.
Thanks, everybody.
All right. Thank you.
Thank you. Night.
Good night.